Did you know that using the AWS SDK between Lambda invocations can be a bad idea? Or that your architectural design might be doubling your costs on AWS Lambda? This is the Serverless Trilemma. My name is Renato and I welcome you to our Serverless Well-Architected Tech Talk series. Before we dive into it, go to dashboard.io/subscribe and make sure you will not miss the next videos. The Serverless Trilemma framework was developed a couple of years ago by a team of researchers in IBM. It helps us evaluate architectures and make decisions considering the trade-offs involved. The framework constraints are Blackbox, double bidding, and substitution. The Blackbox principle indicates that each serverless function should work independently from the rest of the system and no implementation details should be leaked. Consider two functions running on AWS Lambda, A and B. Function A uses the SDK to invoke function B. But what happens if we need to move function B code to another infrastructure? The AWS SDK invocation process will not work anymore. This type of architecture makes it difficult to introduce changes and increases the likelihood of unintended consequences. Function B is leaking its implementation details, thus it's not working as a black box. The leakage is having function A aware that function B is deployed in AWS Lambda. To satisfy the black box principle, we could create an HTTP API, and by routing requests through this API we can decouple the two functions. Later we can just update the API routing to the new infrastructure. This can be extremely valuable as the system and the development team grows. The double billing principle is relatively simple. Two functions should not run at the same time while one is waiting in an idle state for the other to respond. In serverless, we pay for the function execution time, so when function A starts processing and being charged, then it invokes function B and waits for a response, and while B was processing, A continued to be charged despite being idle. Only after B finishes processing is that A can resume its work, and function B processing time is effectively being charged twice. Ideally, we should avoid such situations. Substitution is about having a composition of functions behaving just like any normal function. So what is a composition in the first place? Consider a user requests an invoice from a billing system. You may rely on a second function to apply any discounts available, and yet a third function is responsible for calculating sales tax. All functions are composed to work as a group, hence the name composition. The substitution principle indicates that all three functions together should behave like a function. From invocation methods to timeout to dead letter queue, everything behaves as if they were a single function. The requester doesn't actually know this is a composition of functions, and any developer can rely on this composition without worrying about how it behaves. They just apply everything they already know about serverless functions. This property improves productivity and quality in the overall system. Most of the time it is not possible to have all properties together, so applying the black box principle is usually easy, but when it comes to the other two, there is usually a trade-off. When we prioritize one, such as substitution, it becomes difficult to apply the second, the double billing principle. This framework helps to make architectural decisions and identify what needs to be prioritized in each case. So the black box improves maintainability, scalability, and the resilience by decoupling components. Double billing enables cost efficiency and reduces concurrency level. Substitution enables code reusability and improves quality. What should be prioritized will really depend on each case. We will dive into more details about this decision-making process in the next videos on this series, so stay tuned. Thank you very much.